Hello, we are back again. That's right, once again, it is time for lab number uno, dos, tres, cuatro, cinco, seis. That's right, lab number 6. As always, I'm your host, Christen Andrews. We are doing this for Physics 133, and let's get into it. All right, so as per usual, I am outside today in my backyard. It is a overcast type of day, but not too shabby. This is my working environment today, and let's get into it. All right, so the purpose of today's lab is to explore the relationship between temperature and volume, right? And then to connect this relationship to absolute zero. So that is what we're going to be getting into. Before we get into that, though, let's go ahead and do our inventory check. Moving right along with the inventory check. All right, so number 1, it says we must have graph paper sheet. Well, in this here folder, we have graph paper sheet. Number 2, 10 milliliter sealable syringe with cap. 10 milliliter sealable syringe with cap. Number 3, 8 ounce styrofoam cup. No problemo. I got a whole stack of them right here, although we'll just be using one. Number 4, thermometer. Our beautiful sealed thermometer. Definitely going to be using that today. All right, items that I must provide myself include crushed ice. You can't see it here, but I put it inside this Stanley container. But we got some beautiful crushed ice. My wife loved that kind of crushed ice when she was pregnant. It had to be just that type of consistency. Anyway, number 2 for what I must provide, 1 pencil. Our beautiful pencil right here. Number 3, water. As always, you know I stay with the perfect hydration water. And last but not least, number 4, a stopwatch or timer, which I will be using my cell phone, of course. So now that we're done with the inventory check, let's get into it. Okay, so before I get into these questions, I did want to give a brief recap on the experiment that we conducted today. So finishing up here, as you can see, this is my cold water mixture here with the syringe in place, and the of course the readings, which for me this reached 0 degrees Celsius. Let's see if I can show you guys that right here. See the 0. Hopefully that's in focus. But essentially, let's talk about it. So what took place was, initially we started out with the syringe, and we filled it up halfway. Now I know it's labeled a 10 milliliter syringe, but there are markings on mine, at least, that go and show 12, as you can see there. So what I did was I did half of that container, which was 6 milliliters. Once I did that, I entered it into the hot water in the styrofoam cup and recorded the temperature, and then I made observations as to what happened to the volume in the syringe. Now for me, I pressed down until I couldn't press anymore, released. It actually shot back up past 6 milliliters and went to 8. So to me, that told me that those molecules inside of that, the gas or the oxygen inside the syringe expanded because they were more active. They became active, an increase in activity with an increase in temperature. And that led to an expansion of the volume inside of the syringe. Contrary to that, once I swapped out the hot water for the ice water mixture, then I recorded the temperature, obviously, and then made observations as to the reaction in the syringe. This time, when I pressed down on the syringe and released, it was an immediate difference in terms of the volume inside that syringe. The syringe marker went past 6. It actually went down to 3.5. Once I released, it went up to 4. Now, this told me that the molecules inside of this syringe, inside of the gas that's in the syringe, became less active. And with this less activity came a decrease in volume. So the molecules are not as active. They aren't moving around as they were with the hot water. And so this leads to a decrease in volume inside the syringe. So about to go ahead and get into these questions, make my graph and everything like that. I had a blast with this experiment, lab number 6. I hope everyone else out there did too. And we'll see you on the next one.